In Chapter 4, we'll cover the msp430 clock system as well as the system initialization. We start off by covering the operating modes, and that's how we get from reset to the active mode. We then cover the essentials of the msp430 clocking, the oscillator sources and the internal clocks of the devices. We then step into DCO setup and calibration, and DCO is the digitally controlled oscillator. That is one of the msp430 clock sources or oscillator sources. We finish up with a little bit of a discussion about some other initialization that's needed. The first reset in our list is brownout reset, and you'll actually see there's multiple reset states that the msp430 goes through. Brownout is when the power isn't enough to run the device. So every msp430 device has a brownout reset peripheral, or sometimes we call it a BOR peripheral, that makes sure the device has enough power to run accurately. When the power comes back on, we come out of this brownout into what state we call the brownout reset. You can see on the left-hand side of this slide, there are a number of different things that happen during this mode. So things, certain peripherals are reset, the status register is reset, the watchdog on these devices always powers up and starts running. The program counter is loaded with the reset vector location. So these are pretty standard reset activities. As we said though, the brownout reset is not the only reset that takes place. We can see that other resets, POR, power up on reset, and PUC, power up clear, are two other modes that we step through before we get to the active mode. Each of these states allows the msp430 to clear or reset different conditions or different elements within the msp430. We can see what things, if you go look at the user's guide and or the data sheet, you can see the nomenclature when they describe each register. Under the register, they'll describe what the initial conditions of that register are. And in the lower left-hand corner, where we have circled, we can see that different symbology allows us to determine what things get cleared or reset or set at a particular state. So if there's no parentheses or brackets or anything like that around the initial condition values, you can see that's something that happens in PUC. If we use parentheses, it's POR, and so on. So you can see that we have these different states, different things get reset at different states, as well as on the right-hand side we can see that there are different events that take us to each of these different states. So if we have a reset of the device or a brownout fault, not enough power, that's obviously going to take us to BOR. And from BOR we go through POR, we go through PUC, and finally make it to active mode. On the other hand, if we have a supply voltage supervisor fault, many of the msp430 devices have a supply voltage supervisor. This will actually take us to the POR state and not all the way back to brownout. It's oftentimes convenient not to have everything reset in the part, because that will allow us to try to figure out what brought us to that condition. For example, in PUC, when the watchdog times out, we may want to actually know that the watchdog is the one that timed us out. We want to be able to see what other events had occurred and have some state of the processor. I guess in some ways we might think of these, the PUC, for example, as a warm reset. It doesn't quite clear everything out. So these types of things have existed in other processors, but this is the first one I've ever seen define it in three different states like this. This is an example of the 5529's power-up modes, and you can see that there are the BOR, the POR, and the PUC. But what makes this graphic different is we see all of the different events that can take us to any one of these three states. If you are using a different msp430 device, go look at the user's guide. In the system description, they should give you a similar state diagram to show you what events are available on that processor and which one of the reset states they take you to.